To wrap this chapter up, actually, since we've introduced pretty much all the identities that we're really going to see on a regular basis, we're going to wrap up with revisiting some of the identity proving strategies. So I've really only made one change on my my list of strategies on the left there from what we had before. Before step 2 said simplify any negative angles using those symmetry rules. So now what we're going to do is actually just simplify any insides. So we've got these additive angle rules and double angle rules, so things that make the inside of the trig function more complicated, and we can clean those up now. So that's really going to be the only difference, but it will come up. So we're going to prove this identity on the right. I'm going to start by splitting it into left side and right side. The inside angle is t, which I haven't used before, but that doesn't really matter. We just treat it like theta in any of those identities, or a or b or whatever it has to be. So first, zero step, I don't really see any use of those secondary Pythagorean identities. I don't have any squares whatsoever right now, so probably not that. Write everything in sine cosine. That I can do right now. I've got a couple of tans. So I'm going to use step 1 here on both of them to get sine 2t minus, that'll be sine t over cos t. And the right side will be sine t over cos t times cos 2t. And so I can't do any cancellation on those right coses because they're different. That 2t on the inside, it's very, very different. So I have to be careful there. Combining fractions. Sorry, no, I'm on step 2, simplify the inside. So that is definitely what I can do here. I've got those 2 t's. And so that is going to allow me to apply, that's step 2. So we just use those formulas from before, but sine 2t is 2 sine t cos t, right? So 2 times sine of the first, cos of the second, and then minus sine t over cos t. And yeah, so that cos t 2t is cos squared minus sine squared. Maybe use one of those other variations on it, but I'll see if those work later. So I'm just going to default to this initial one. Yeah, so I've got this so far. Now step 3 would be combining fractions. I can definitely do that. I could maybe distribute some stuff on the right, but I don't know if it's going to do much. But here there's definitely a fraction that's separated from another term. So I'm going to combine over the common denominator. So the least common denominator would just be cos t. And so on the left there, what I'm going to need is to multiply the top and bottom by cos t. So what I should end up with is another cos t on that term. So I'll square it. And all of that over the cos t. And so keeping in mind, I'm trying to make this thing look like the right. I've combined the fractions. The way that this is written, I don't see any variations on the Pythagorean identity. Cos squared minus sine squared is very different than plus, so I don't really have any of those. Should probably go ahead to simplifying. So if you'll notice on the right, it's very much factored. On the left, I probably want this factored to make some kind of comparison point there. So on the left, I can factor sine from the top. And what I'll be left with is 2 cos squared t minus 1 over cos t. And these two things don't look exactly the same, but you might, if you remember the double angle formulas, you might recognize that on the left. If not, there is a way to get around it. What I can see here is that the left and the right are pretty close to each other right now. I've got this sine t over cos t. And so what we need to do is get these other little bracketed parts to be exactly the same. We're trying to show now that these two things are the same. So if I wanted to do that, I might notice that on the left, this chunk in the bracket is just coses. On the right, I've got a cos and a sine, so maybe what I should do is turn the sine into cos. And that's where the Pythagorean identity comes in. It allows us to take squares of things and easily transfer them into something else. And so I'll get sine t over cos t, cos squared t, minus, and I'll use that Pythagorean identity, sine squared t is 1 minus cos squared t. And so yeah, that is just the Pythagorean identity, step 4 there. And just label my steps. Yeah, and then if you just clean that up, you'll see it is in fact the exact same thing as we have on the left. So that's 2 cos squared t minus 1, and I'm done. So that one's proven. Yeah. All right, so a second one, we're going to prove this identity, sine of alpha minus beta over cos alpha cos beta equals tan alpha minus tan beta. I'm going to split this up. Multiplication between cos alpha and cos beta. Yeah, and just making our way through the steps. I don't see any tan squares or secant squared, so that 0 step doesn't seem any good to me. Rewrite everything in sine cosine. I can definitely do that on the right with those tans. So that's going to be sine alpha over cos alpha minus sine beta over cos beta. Combine the simplifying the inside. So we've got right here that alpha minus beta that I'm going to want to tear apart. So this will be equal, and then use my difference formula. So sine of the first, cos of the second, minus cos of the first, sine of the second, and then divided by cos alpha, cos beta. Now combine any fractions. So on the right side, I've got a sum of 2 sort of fractional pieces. So I'm going to combine them over cos alpha, cos beta. Which, if you'll note, that's actually the same denominators on the left-hand side. So that seems pretty good. So the left term is going to be multiplied by cos alpha over cos beta over itself. So I'm going to get sine alpha cos beta over cos alpha cos beta, and then minus sine beta cos alpha over cos beta cos alpha. And then we should be able to combine, and you'll see across the top, we have exactly the left-hand side here. So we're good. Over cos alpha cos beta equals the left side, and we are done. Okay, and just one last one to try to cover all our bases here. So we're going to prove this identity with just a whole bunch of cos going on here. So my left side is 1 plus cos theta. Probably not much that we're going to do with that. And the right side is pretty messy, so we should be able to get some work done over here. So cos 2 theta minus cos squared theta over cos theta minus 1. No tan squared or secant squared, 0 doesn't apply. Everything's written in sine and cosine. In fact, everything's just written in cosine. And simplifying those insides. So that's obviously going to be what we're seeing for a lot of these questions. So cos 2 theta, I'll just use the typical substitution there of cos squared theta minus sine squared theta. So that would be step 2. And then minus cos squared theta divided by cos theta minus 1. And combining fractions, it's all written currently over one big fraction. Maybe what I'll actually do is clean this up a bit. You'll notice that the cos's cancel, so I might as well do that before I start plowing ahead with steps. So this is actually negative sine squared theta over cos theta minus 1. Yeah, so that's just simplifying. Yeah, so it's just it's combined in one big fraction, so I can't do anything there. Looking for cos squared plus sine squared. No, I don't see that. I don't see any obvious incarnations of that Pythagorean identity. I can't simplify either side at all. And so everything else is exhausted, but the left side and the right side don't look equal. So if you remember that conjugate, that is definitely what I'm going to apply here. So what I'm going to do is multiply. I can see along the bottom, I've got this cos theta minus 1. So I'm going to multiply by its conjugate. So just changing the inside from a minus to a plus, or a plus to a minus if that were the case. And what that's going to allow me to do here is write the bottom as that difference of squares, cos squared theta minus 1. And then that should pretty much always put you back to step 4, which is nice. I mean, it's not nice that we're moving backwards, but it's nice that it'll always allow you to use this Pythagorean identity if it's been done correctly. So yeah, I've got that cos squared theta minus 1. So what I'm going to use is this variation here, 1 minus cos squared theta, right? Because that one's 1 is actually equal to sine squared theta. So that means that this is actually the exact negative of that. So it's negative sine squared theta. And that is my Pythagorean identity. So I'll have negative sine squared theta over cos theta plus 1 over negative sine squared theta. And we'll get the cancellation there, and we are left exactly with the left-hand side. And we're done. So that's probably about as tricky as it'll get. But yeah, there you go. We can do a whole bunch of new identities. If you follow those 6.5-ish steps on the left, you should be able to plow your way through any of these identity proofs.